Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, yang ni yang part kedua untuk sambungan Google Cloud Model 3. Part pertama tu kita dah tengok Compute Engine. Compute Engine ni under Infrastructure as a Service lah. And kita tengok another service called App Engine. But this one is under Platform as a Service, so focus on coding. So for today, we're going to go through Cloud Function and Kubernetes. So for the developer, agility comes from building systems composed of small independent units of functionality focused on doing one thing well. So Cloud Functions lets users build and deploy services at the level of a single function, not at the level of entire applications, containers, or virtual machines. So cloud functions are ideal if you need to connect and extend cloud services and want to automate with event-driven functions that respond to cloud events. It's also ideal if you want to use open and familiar Node.js, Python, or Go. So while never managing a server or runtime. So Cloud Functions provides a connective layer of logic that lets users write code to connect and extend cloud services. Users can listen and respond to a file upload to cloud storage and log change or an incoming message on a pub subtopic. Cloud Functions have access to the Google service account credential and are therefore seamlessly authenticated with the majority of the Google Cloud services, such as Data Store, Cloud Spanner, Cloud Translation API, and Vision API. So cloud events are things that happen in the cloud environment. These might be things like changes to the data in a database, files added to a storage system, or a new virtual machines instance being created. So events occur whether or not users choose to respond to them. And users can create a response to an event with a trigger. A trigger is a declaration that they are interested in a certain event or a set of events. Binding a function to trigger allows them to capture and act on events. So Cloud Functions remove the work of managing servers, configuring software, and updating frameworks and patching operating systems. So the software and infrastructure are fully managed by Google, so that users just add code. Furthermore, provisioning of resources happens automatically in response to events. This means that a function can scale from a few invocations a day to many millions of invocations without any additional work for users. So events happen all the time within the system, like file uploads to cloud storage, changes to database records, requests to HTTP endpoints, and so on. So by writing code that runs in response to those events, Cloud Functions runs it while automatically managing any underlying infrastructure. Cloud Functions connects and extends cloud services with code, so you can treat them as a building blocks. and adjust them as your needs change. So you can also extend your application using a broad ecosystem of third-party services and APIs. So a cloud service emits some kind of event. This can be a pub sub message, a change to cloud storage object, or a webhook, for example. The event kick off a cloud function. The function can be written in Node, Python, or Go. The function can invoke other services and write back the results. Building infrastructure is not required when leveraging cloud function. So there is another lab, so please do that. So in this lab, we will create, deploy, and test a cloud functions using a Cloud Shell command line. So by completing the lab, you will create a simple cloud function, deploy and test the function, and view the log. So in this final topic, we will learn how to leverage Google Kubernetes engine. So we've already discussed the spectrum between infrastructure as a service and platform as a service. And we've already discussed compute engine, which is the infrastructure as a service, offering of Google Cloud with access to the servers and file systems and networking. Now we will introduce you to containers and JKE, the Google Kubernetes Engine, which is a hybrid that conceptually sits between the two, offering the managed infrastructure of an IaaS with the developer orientation of PaaS offering. So JKE is ideal for those that have been challenged when deploying or maintaining a fleet of virtual machines, and it's been determined that containers are the solution. It's also ideal when organizations have containerized the workloads and need a system on which to run and manage them. And don't have a dependency on kernel changes or on a specific non-Linux operating system. With JKE, there's no need to ever touch a server or infrastructure. So how does containerization work? So infrastructure as a service allows you to share compute resources with other developers by virtualizing the hardware using virtual machine. So each developer can deploy their own operating systems, access the hardware, and build their applications in a self-contained um, environment, a self-contained environment with access to their own runtime libraries, as well as their own partitions of RAM, file system, networking interfaces, and so on. You have your tools of choice on your configurable system. You can install your favorite runtime, web server, database, or middleware. Configure the underlying system resources, such as disk space, disk I/O, or networking, and build as you like. So, but flexibility comes with a cost. The smallest unit of compute is an app with its virtual machine. The guest OS may be large, even gigabytes in size, uh, and takes minutes to boot. As demand for your application increase, you have to copy an entire virtual machine and boot the guest OS for each instance of your application, which can be slow and costly. So with platform as a service, you can access to hosted programming services. All you do is write your code in self-contained workloads that use these services and include any dependent libraries. Loads do not need to represent entire application. They are easier to decouple because they are not tied to underlying hardware, OS, or a lot of the software stack that you use to manage. So as demand for your application increase, the platform scales your application seamlessly and independently by workload and infrastructure. These skills rapidly encourage you to build your applications as decoupled microservice that run more efficiently, but you won't be able to fine tune the underlying architecture to save costs. So that's where containers come in, and the idea of container is to give you the independent scalability of workloads in PAS, platform as a service, and an abstraction layer of the OS and hardware in infrastructure as a service. So it only requires a few system calls to create, and it starts as quickly as a process. All you need on each host is an OS kernel that supports containers and a container runtime. In essence, you are virtualizing the OS. It scales like PAS, platform as a service, but give you nearly the same flexibility as infrastructure as a service. So containers provide an abstraction layer of the hardware and OS, an invisible box with configurable access to isolated partitions of system, RAM, and networking, as well as fast startup with only a few systems core. If you want to scale, or for example, a web server, you can do so in seconds and deploy any number of containers depending on the size of your workload on a single host or a group of hosts. So you will likely want to build your applications using lots of containers, each performing their own function like a microservice. So if you build them this way, connect them with network connections, you can make them modular, deploy them easily, and scale independently across a group of hosts. And the host can scale up and down and start and stop container as demand for your application changes or as hosts fail. With a cluster, you can connect containers using network connections, build code modularly, and deploy it easily, and scale containers and hosts independently for maximum efficiency and savings. So Kubernetes is a container orchestration tool you can use to simplify the management of containerized environments. You can install Kubernetes on a group of your own managed servers or run it as a hosted service in Google Cloud on a cluster of managed compute engine instance called Google Kubernetes engine. So Kubernetes makes it easy to orchestrate many containers on many hosts, scale them as microservice, and deploy, roll out, and roll backs. It was built by Google to run applications at scale, and Kubernetes lets you install the system on local servers in the cloud, manage container networking and data storage, deploy, rollouts, and rollbacks, and monitor and manage container and host health. So just like shipping containers, software containers makes it easier for teams to package, manage, and ship their code. They write software applications that run in a container. The container provides the operating system needed to run their application. The container will run on any container platform, and this can save a lot of time and cost compared to running servers or virtual machines. Like a virtual machine imitates a computer, a container imitates an operating system. Everything at Google runs on containers, Gmail, web search, maps, reduce, batch, Google file system, Colossus, even cloud functions, which machine in containers. And Google launch over 2 billion containers per week. Docker is the tool that puts the application everything it needs in the container. Once the application is in a container, it can be moved anywhere that we run Docker containers. Any laptop, server, or cloud provider. This portability makes code easy to produce, manage, troubleshoot, and update. For service providers, containers make it easy to develop code that can be ported to the customer and back. Kubernetes is an open source container orchestration tool for managing a cluster of Docker Linux containers as a single system. It can be run in the cloud and on-premise environments. It's inspired and informed by Google experience and internal systems. So JKE Google Kubernetes Engine is a managed environment for deploying containerized applications. It brings Google's latest innovation in developer productivity, resource efficiency, automated operation, and open source flexibility to accelerate time to market. So JKE is a powerful cluster manager and orchestration system for running Docker containers in Google Cloud. So JKE manage containers automatically based on specifications such as CPU, memory. It's built on the open source Kubernetes system, making it the easy for users to orchestrate containers, clusters, or group of containers. Because it is built on the open source Kubernetes system, it provides customers the flexibility to take advantage of on-premises, hybrid, or cloud infrastructure. Next, ada lab untuk GKE. So in this lab, we'll get hands-on practice with container creation and application deployment with GKE. So by completing the lab, you will set a default compute zone, create a JKE cluster, get authentication credential for the cluster, and deploy an application to the cluster. So right now, we will complete our final lab for this module, and we shall focus on network load balancer. So in lab, we will learn the difference between a network load balancer and HTTP load balancer, and how to set them for your application running on compute engine machine. So please pay attention on this lab. Might come out in the exam. By completing the lab, you will set up a network load balancer, HTTPS load balancer, and learn to differentiate between network load balancers and HTTP load balancers. So summary, there are 4 different compute options in the cloud to choose from. First, compute engine, app engine, cloud functions, and Google Kubernetes engine. Compute engine and infrastructure as a service delivers virtual machines via Google's data centers and global fiber network. Auto-scaling controls manage instance groups. App engine is computing platform provided as a service, allowing users to focus on writing code, not on infrastructure. Cloud Function is a serverless option that connects and extends cloud services and automates with event-driven driven functions that respond to cloud events. JKE is hybrid between compute engine and app engine. It's a managed environment for deploying containerized apps. Okay, that's all. That's all for module 3. Later we will continue with module. Okay, thank you everyone. If having any problem or having any questions, please email or WhatsApp me. Thank you.